Good evening, everyone, respected dignitaries, my faculty colleagues, and dear students. Welcome to all of you in a one-day lecture on an overview on transformers and its uses, jointly organized by Electrical Engineering Department, IIEST Shibpur, and GAABESU. Today we feel honored to have with us our alumni Sri Dhruba Jyoti Chakraborty as the speaker of this event. Now I would like to call all the dignitaries to come on the dais. Dr. C.R. Mahato. Yes, sir, please. Our HOD Madam, Professor Anindita Sengupta, Professor Voltamp Banerjee, and Professor Indranath Sinha.
Indranath is not there.
And also Dean IRAA. Now I would like to request our HOD Madam to deliver the welcome address to the audience.
A very good afternoon to all of you present over here. This is a great opportunity to welcome you all in this one-day lecture program organized jointly by the Department of Electrical Engineering and GAABESU. You all are aware of the fact that on 23rd August 2024, Department of Electrical Engineering and GAABESU have tied a knot with the focus that we jointly will be organizing some program where primarily the technical lectures will be delivered and different interaction sessions between the present students and the alumni members will be organized so that their experiences will enrich the current students. Under this umbrella, the first lecture program, that is Dr. S.K. Sen Memorial Lecture Program, was organized on 23rd August 2024, where we also got another alumnus and illustrious lecturer, professor of this department, Professor A.N.G. And this was that program was a grand success. Under the same umbrella, we thought that we should organize a board program whose primary focus is to envisage the visibility of this department to the outer world. With this in mind, we were actually requested by GAABESU that one more program may be organized with Sri Dhruba Jyoti Chakraborty as a speaker who will be talking primarily on transformer and some of the industrial aspects of the particular instrument. So today is the time when we are meeting to hear from him, and we feel that our students will be immensely benefited with the tidbits what he shared with his vast experiences. I feel that this is an amalgamation of the feeling by the nostalgic alumnus and the enthusiast current students, and with a view of great interaction with the speakers and my dear students. I will finish here, and I shall request the anchor to invite our Dean Sir first because he has some other busy schedule, so that he can share his ideas and views with the audience, and then the other dignitaries present on the dais. Thank you.
Thank you, madam, for briefing this program. Now I would like to call Dean IRAA to speak a few words to the audience.
Respected Professor C.R. Mahato, Professor Voltamp Bandyopadhyay, HOD Madam, Professor Anindita Sengupta, and other dignitaries of 1980 batch, respected alumni of this institute, other faculty members of this department, and I can see Professor N.C. Dey from mining engineering, and dear students. A very good afternoon to all of you. I will not take much time. I am here to express my sincere thanks to the Electrical Engineering Department for conducting this tie-up between them and GAABESU for organizing this type of lectures. Now, it has been told and by our director sir and by our chairperson madam of DOG, repeatedly they are asking for alumni lectures because this institute can really boast of vast alumni present, not only in India but also in abroad. And all of them are in very key positions. So once they are retiring, they are still with full of energy, and it is the onus on us. It should be our duty to utilize their vast knowledge and still the energy present in them. I am extremely thankful to Mr. Dhruba Jyoti Chakraborty, who has an enormous experience throughout his life, initially in the area of motors, electrical motors, and now in transformers. He has spent almost 20 years of his valuable professional life in this arena. Now, I believe, although I am not an expert in this area, but I still believe that transformer has an elaborate presence in the UG and PG curricula of this department. But I must say that I am slightly not so happy to see the presence of so many students. Maybe it's a weekend, but still, the students must be told that these kind of lectures are very rare and they are extremely valuable. Since it is available free of cost, they should not undermine this. These kind of lectures are not available. A person with 20 years of experience in the field of transformers is going to give a lecture, and that is a fantastic value for all professionals, those who are going to take up their professions in this field or even not in this field. But interaction with the presence of this kind of personality is a great scope, I think, and they must use this scope. So I will not delay this program any further. I will express my sincere thanks once again to the alumni for being here and also the department for organizing this kind of seminar. The first one was at the alumni seminar hall, and this one, if it continues, more number of alumni lecture series are conducted, then it will be extremely beneficial not only for this department but also for other departments, and it should be taken as an example for other departments to institute this kind of lectures. Thank you. I would just like to be excused because I have to leave now. We have 26th January celebration committee. I have been made the FIC, so I have to see the preparedness. So please excuse me. I have to leave the venue right now. Thank you.
Thank you, sir. So from the next time, in future, we will try to encourage more our students to participate in such kind of programs. Now, it's my immense pleasure to call Professor Voltamp Bandyopadhyay, ex-professor and ex-HOD to enlighten us with few words about senior ex-professor of our department, Professor C.R. Mahato.
A very good afternoon to all of you. It's wonderful to be here at the invitation of GAABESU, Global Alumni Association of Bengal Engineering and Science University. Now, during its long journey, our institute has changed its name several times. So, prior to becoming IIEST, it was GAABESU. I do not know whether all of the present students are aware of that thing. GAABESU means Bengal Engineering and Science University, and GAABESU is actually our alumnus alumni association, and GAABESU has retained its earlier name. I have been asked to say something about Professor Chittaranjan Mahato. Now, since I was a student of this department way back in 1970s, actually I was in this department as an undergraduate student during the period 1971 to 76. So I know Professor Mahato, I think slightly more than 50 years. I still vividly remember the very first encounter with Professor Mahato. I do not know the exact reason, but he didn't take any theoretical class in our batch. I do not know, but he was there in some laboratory. Now, one day, most probably in the measurement lab, after finishing my assigned experiment, two of us, myself and one of my friends, we were roaming around the laboratory. And on one corner of that laboratory, there was an experimental setup in a glass cover. Now, I put my head inside that box-like structure, and suddenly somebody told me, "What are you doing over here?" And I looked back and found Dr. Mahato was asking this question, and my friend pointed his finger towards me, and he answered that he wants to know what is the function of this setup. Now, Dr. Mahato then told me, "Who told you that you need to know everything?" I got embarrassed, but then with a smiling face, he told me that right now you concentrate on the experiments that have been assigned in this year, and you will come to know about all these things later. With a smiling face, he was very affectionate. I still remember 50 years have passed, but I still remember vividly that incident. Afterwards, in the year 1986, 30th August most probably, I joined this department as a lecturer, and he was my senior colleague. So whenever I faced any technical problem or had some confusion, I used to approach him, and most of the times he gave me a very satisfactory solution, or at least he guided me to proceed towards a meaningful direction. So I am a great admirer of him even this day. I remember one such incident. Myself and Professor Roshit Sham at that time was doing some sort of research work on induction motor, and that was related to auto changeover. That means some motors are connected to a bus. Now, if something goes wrong with the supply, then another supply is automatically connected to that bus, and the in-between time is very short. This is done automatically by some arrangement. So now if you switch off an induction motor, But if you watch the waveform or watch the waveform of the voltage across it, you will notice that the voltage across the terminals will not die down suddenly. The moment you will switch off, it will not be zero. It is because of the fact that the rotor circuit is an inductive circuit and it was carrying some current. So in an inductive circuit, current cannot die down instantly, abruptly. So it will keep on flowing for some time, and during that time period, rotor current will flow, so there will be some flux in the air gap, and that is why you will get some voltage across it. And the waveform from the published literature, we came to know that it will be exponentially decaying sine wave. But in the experiment, while we were carrying out the experiment, we failed to obtain that exponentially decaying type of waveform. Then we concluded that in the book, maybe you may find this type of things, but in reality, because of some reason or other, you may not find it. But then I approached Dr. Mahato, and he told us, you just use a conductor instead of a hand-operated switch, manual switch. You just switch it off using some contactor. The moment we changed it that way, we got a waveform which is as good as the figures that we usually get in the published literature or in standard book. So I still remember this thing. Now, after my retirement, I retired from this department in the year 2020. Now, you told me, actually, I know a lot of things about Dr. Mahato. He is also a student of this department. He passed out in the year 1961, and he did his ME in the year 1964. Afterwards, he went to Soviet Russia in the late 60s. He was there for 2 years, and then he came back again. Let me cut it short. After my retirement in the year 2020, I joined a forum of retired teachers, which is known as ex-faculty forum of the college. So, as because among the retired teachers, we belong to the junior group, I was assigned some responsibility, and just in the last year, we published a magazine. And when I approached Professor Mahathir, he was willingly gave us some paper on philosophy. Apart from electrical engineering, he has other interest and he has a great knowledge in those areas. I really feel that I'm very fortunate to get a teacher like Dr. Mahathir, and I wish him a long, healthy life. With this, I conclude. Okay.
Thank you, sir. Now I would like to request Professor C.R. Mahato to speak a few words. Sir, please.
তোমার কিছু বলার প্রোগ্রাম ছিল না, আমি ভেবেছিলাম দর্শকের আসনে বসে বা শ্রোতার আসনে বসে আমি একটু শুনবো, কিন্তু তারপর আমি কিছু বলার জন্য প্রস্তুতিও আসি। আর তাছাড়া ডিপার্টমেন্টে যখন ছিলাম তখন প্রায় সব সাবজেক্টই আমি পড়িয়েছি, বেসিক ইলেকট্রিক্যাল থেকে আরম্ভ করে কন্ট্রোল সিস্টেম ডিজাইন, সার্কিট থিওরি, ইলেকট্রিক্যাল মেশিন ডিজাইন, প্রায় সব সাবজেক্টই পড়িয়েছি। কিন্তু তারপরে রিটায়ারমেন্টের পরে আমি ডোমেনটা একেবারে পাল্টে ফেলেছি। এখন আমি আর কনভেনশনাল ইঞ্জিনিয়ারিং বা কনভেনশনাল ইলেকট্রিক্যাল ইঞ্জিনিয়ারিং নিয়ে কিছু করি না। আমি যে দুটো ডোমেনে কাজ করি সেগুলো ইঞ্জিনিয়ারদের কাছে একটু বেখাপ্য। একটা হলো হোমিওপ্যাথির সায়েন্টিফিক বেসিস, হোমিওপ্যাথি প্র্যাকটিস কিন্তু নয়, ক্লিনিক্যাল সাইড নয়, রুগী দেখান নয়। আরেকটা হলো যেটা প্রফেসর বন্দ্যোপাধ্যায় বলছিলেন যে ফিলসফি, আমি ঠিক ফিলসফি চর্চা করি না, আমি স্পিরিচুয়ালিটি বললে বোধহয় সঠিকভাবে বলা হবে। আমি স্পিরিচুয়ালিটি নিয়ে চর্চা করি এবং সেই স্পিরিচুয়ালিটি আমাদের ইন্ডিয়ান ফিলসফি বা ইন্ডিয়ান স্পিরিচুয়ালিটি যেটা টপ অর্ডার ধরা হয় সেটা হলো বেদান্ত ফিলসফি। ইনফ্যাক্ট আমার নাড়াচাড়া ওই বেদান্ত ফিলসফি নিয়ে, এবং ভাবনা বলে যে পত্রিকাটা বেরিয়েছে এখান থেকে, সেটাতে যে আর্টিকেলটা আমি দিয়েছি সেটা হলো স্পিরিচুয়ালিটি। তো সেগুলো নিয়ে আমি কিছু পড়াশোনা বলবো না, কারণ এগুলো প্রায় সকলকেই বোর করা হবে। ইন্টারেস্টেড ইয়ে থাকে, স্পেশাল কোনো প্রোগ্রাম অ্যারেঞ্জ করে দিতে তখন সেগুলো বলা যাবে। আপাতত আমার ইলেকট্রিক্যাল ডিপার্টমেন্ট সম্বন্ধে যা এতে, আমি এখানে ছাত্র হয়ে ঢুকেছিলাম 1955 সালে, সরি 1957 সালে, সেন্টেনারি হলো তার ঠিক পরের বছরে। তারপরে এখানে থেকে বিএ পাস করেছি, এখান থেকে এমএ পাস করেছি। ইনফ্যাক্ট আমি রাশিয়াতে গিয়ে 2 বছর ছিলাম, কিন্তু আমার ওখানে জমা দেওয়া হয়নি, আমি এখানে এসে ক্যালকাটা ইউনিভার্সিটিতে জমা দিয়েছি। অতএব সেই সময় কিন্তু বিই কলেজ পুরোপুরি ক্যালকাটা ইউনিভার্সিটির আন্ডারে ছিল। অতএব আমার বিই, এমএ, পিএইচডি ডিগ্রি সবকিছু কিন্তু ক্যালকাটা ইউনিভার্সিটির আন্ডারে ছিল। এবং এই সারা জীবনে বলতে গেলে আমি বিই কলেজেই কাটিয়ে গেলাম। ছাত্রাবস্থায় ঢুকেছিলাম 1957 সালে, রিটায়ার করলাম 1999 সালে। এবং তার উপরেও আমি এখন যে পুরোপুরি বিই কলেজের টান কাটিয়ে ফেলেছি তা না, কারণ আমি থাকি একদম হসপিটালে একটা হাউসিং অ্যাপার্টমেন্ট আছে, উদয়ন অ্যাপার্টমেন্ট, আমি সেখানেই থাকি। এবং তারপরে বিই কলেজের রিটায়ারমেন্টের পরও আমি বিভিন্ন ক্যাপাসিটিতে ছিলাম। কখনো ছিলাম অ্যাডজাঙ্ক্ট প্রফেসর, কখনো ভিজিটিং প্রফেসর, কখনো এমারিটাস সায়েন্টিস্ট, বিভিন্নভাবে ছিলাম। তারপরে 6-7 বছর আমি মানে 1 ঘন্টা লেকচার দেওয়া আমার পক্ষে তখন কষ্টকর হচ্ছিল আর কি। তো সেই কারণে আমার লাস্টের অ্যাসাইনমেন্ট আমি আর অ্যাকসেপ্ট করিনি, আমাকে দেওয়া হয়েছিল কিন্তু আমি আর অ্যাকসেপ্ট করিনি। এবং তারপরে প্র্যাকটিক্যালি আমি আমার ওই যে দুটো ডোমেনে বললাম, সেই দুটো ডোমেনে আমি কাজ করি। মস্ত বাড়িতে বসে আজকের মতো এমনি আছি। এবং আজকে এখানে এর সঙ্গে আমি ইঞ্জিনিয়ারিং সম্বন্ধে কিছু বলছি না, আমার ডোমেন সম্বন্ধে কিছু বলছি না, শুধু বিই কলেজে যে আমার যে কটা দিন কাটিয়েছি, যে কটা বছর কাটিয়েছি, বিই কলেজটা একটা হোমলি এনভায়রনমেন্ট ছিল। জানি না এখন যে হোমলি এনভায়রনমেন্ট কতটা আছে। এখানে যারা আছেন ছাত্ররা কেউ জানবে না, প্রফেসর পিকে নন্দী, প্রশান্ত কুমার নন্দী, উনি কানপুর আইআইটিতে পিএইচডি করতে গেছিলেন। হি ওয়াজ অলসো অল স্কয়ার, সমস্ত সাবজেক্টে করেছিল। তো প্রশান্ত নন্দীকে কানপুর আইআইটিতে ওটা অফার করেছিল, তুমি আর বিই কলেজে ফিরে যাবে কেন, তুমি আমাদের এখানে জয়েন করো। বলে দেখো তোমাদের এখানে আসবো, একটু রিসার্চ করবো, এই করবো, সে করবো, কিন্তু চাকরি করার জন্য তোমাদের জায়গাটা আমার পছন্দ না, আমি বিই কলেজে যাচ্ছি, দ্যাটস মাই সেকেন্ড হোম। এবং সেই কারণে বিই কলেজে তোমার এনভায়রনমেন্ট খুবই হোমলি ছিল। জানি না সেই হোমলি এনভায়রনমেন্ট এখন আছে কি না, কিন্তু আমি সেই পিরিয়ডটা কাটিয়েছি 1999 পর্যন্ত বেশ হোমলি এনভায়রনমেন্ট। আশা করি তোমরা সকলে হোমলি এনভায়রনমেন্টে নিজেদের মধ্যে পারস্পরিক আদান প্রদান করে থাকবে, এইগুলো আমি শেষ করছি। ওকে, থ্যাংক ইউ।
Thank you, sir. Thank you very much. Now we are going to start our lecture. First, I would like to request Sri Moloy Niyogi, alumni of our department, to introduce our respected speaker, Sri Dhruba Jyoti Chakraborty.
Good evening, respected Mahatusha, HOD Anandita Madam, Voltamp sir, আমাদের very close in GAABESU also, and all other my friends, my batchmates, and all students, including those who are in the Zoom. I welcome you all in this lecture session. It's not a lecture session, we can say. It's just a talk. As all of you people are getting day-to-day studies and all lectures from your teachers who are very much capable in your academic area. But to have give you some idea before going to the actual working field or industry, we want to share some of our experiences. Actually, myself, Moloy Niyogi, we have passed in 1980, and all of the students never not born that point of time, I should say. So we want to share our experience, long 44 decades experience, and Dhruba Jyoti is one of my best friend, and he got the opportunity to, and in our time there was no such campus interview very much, unlike this time. So that time very few organizations used to come for our campus interview. So from that campus interview, Dhruba Jyoti and Sajol and some few other friends, they have got the opportunity to join Crompton Greaves from the campus itself. So they got posted in Ahmednagar, as far as I remember. That's a very remote place in Gujarat. So they went there, and Dhruba Jyoti was there for 17 years. Initially, he was joined in design and then shifted to marketing and all. So he rather shifted the department with one of our another friend who was not interested in marketing, and he took the design and he changed over to marketing section. So he did the marketing as well as all the basic. Definitely, you have to know the basic. Otherwise, you cannot market any item. So one of the core items like motors and transformer, these are the two core items in electrical engineering and power system and also. So this is one of the area, and with his practical experience of all these more than 4 decades, he will share these details with you, and I think you will gain some knowledge from his lecture. And one thing I want to show, especially for those who want to be in the core field after your academic life. So most of the thing nowadays they are very much interested in software and all these sectors, which is more lucrative for you. Immediately after joining the industry, you might get a good handsome salary. But in core sector, people are not interested, not getting that much interest because of the low salary and all. But if you stick to your core field, if you are a technical person, if you are studying engineering and technical side, if you wish to keep your knowledge sharing with others and gain experience and all these things, either you have to be in academic in your core field, or you go to the industry in the core industries. And in our time, there was not. I told that there was not such campus interview, we used to look at that BHEL, SAIL, GAIL, ATPC, all this. They used to take some written test, then interview, and all this. After all these hassles, we used to get the services to the industries. So all my friends, few friends are there who are from. I will get them introduced afterwards, but they are from all different kind of industries. Some of them we may get later also with discussion with Anindra madam. So regarding Dhruba, I should say after he worked in Crompton for 17 years, then he switched over to Voltamp, and he was there for 20 years. He retired there from as a executive director in marketing, and still now he is working with another organization, Atlanta Electric, like that. So he is also there as a senior marketing head and all. So he's still in the market, and apart from the technical side, Dhruba is having a very good extracurricular activity, extracurricular side that which we know among our friends. He is a very good writer. He is a very good, drama script writer, drama artist, and he used to write poems. He used to write so many articles. And in fact, yesterday on Netaji's birthday, I recited one. Not I should not say it's a poem. It's a write-up. It's a imaginary write-up on Netaji, which I read out or I recited, written by Dhruba. So I have already recited some 4 or 5 poems of him, and he's very much, and he's a very jovial. He's a good actor, and he can keep the audience in very jovial mood and a very lively session. So I welcome Dhruba Jyoti to come over, take over the charge, and student also please be listen to him. And whenever the question answer sessions come, you please ask any question you want to know. So he will answer as far as his knowledge is and experience is concerned. So thank you all for joining us, and I invite you to go. Jyoti, please come. Thank you.
This side? This side or that side? Okay, no? You can see us? See me?
Just ফ্লাওয়ার বুকেটা একটু সরিয়ে দিয়ে এটা থাকলে না একটু অসুবিধা হয়।
Hello. I think you all can see me and hear me also. So good evening, everybody. It is, I must say, all due respect to my senior dignitaries over here. First of all, I am overwhelmed that to see Dr. Mahato over here. He was our very, very beloved professor. As he said, all the branches of electrical engineering he taught us, and we were the student of him. I really never expected this kind of honor that he will present over here in my speech. It's a different kind of feeling when you all grow up to come back to alma mater, and when you see your professor over here, I don't know how to express that feeling. Thank you, sir. Thank you very much. First of all, transformer, I just got hooked up. I initially started my career with induction motors, but interestingly, I find that transformer is a very interesting subject, which I just got involved into it and started liking it. I remember those days when we first learned about transformers in this college, in one of this classroom. We are asked to design a transformer. So theoretical knowledge, I just share with you the theoretical knowledge and the practical things, what difference it makes. We were given all the inputs, and we had a designer books also in hand. With that help, we designed one. Of course, it was a homework for us. So all sat together, used our brains, and designed the transformer, 1000 kVA transformer, 33 by 11. we found the size of the transformer was more than 2-story building, and it is fact. So this is the basic difference between our technical as well as when we go to the industry. A lot of things comes into picture. It is not only that the design itself is perfectly all right, but still you will not get into that the practical things. So when I got into the transformer field from motor, induction motor, I find very interesting subject. Both the products are having your primary and secondary. One rotates and one is stationary, but both have primary and secondary windings. So this is why it attracted me. How it happens. So gradually I started interested in this subject and became the part of the transformer. So that way I got hooked into the transformer field. Otherwise, transformer every knowledge is from my basic in this one practical field that I have whatever I gained. Fortunately, with the organization where I worked, so I got the opportunity to see both sides of the table, how to design a transformer, how to make usable in the field of industry, and how to sell it. If you make a 100% efficient transformer, it might not get sold in the market because customer wants. Don't give me gold, I want copper. Don't give me copper, I want aluminum. So you have to manage, you have to master the trick, what customer wants. One of my general manager used to say that customer is always right because he has got money. So our point of view was that to make a product which is sellable in the market, consumable in the market, and to some extent this applies, they give the actual product value. So that was the objective of that. So that's why both technical as well as the commercial point of view, this product has ideally owned my heart. Show the slide. Next. This is basically a sneak peek. I am not going to go. This module is basically meant for the students so that you will get some knowledge about it. There are a lot of experts are sitting here. My friends, those who have worked in the user's point of view, they know ins and outs of this product. To whom I have also sold my product, is also working with them in this one. So they can strip me down here, but still I will give you this model as far as the student is concerned. When they will come enter into the industries of this kind of field, at least they will have some product knowledge on this. Based on that, this presentation has been prepared. Now here, before I go to my next slides, I say that always say the progress of science does not cease to scale the new heights. There is no answer. It is basically gets stopped because there is no question. So I want to invite questions from you. I may not be able to answer all the questions because in this field it is so vast. None, I must say that it is very difficult to answer all the questions. It might be very, very dumb questions also, but don't stop asking the dumb question also because it opens a new avenue for the people, those are involved in this field. We want out of the box kind of questions which we never thought of. When I look at my product, I know it is fully fantastic product I'm manufacturing. But it's not like that. Somebody else is going to use it. He knows better. We always say we learn from customers because every manufacturers will be designing as per the feedback of the users, what he faces. In the urban field, when a transformer is placed, the most difficult scenario we feel not because of the technical things. We find a problem with the space. We don't have enough space in the cities to install a transformer. So we have to design a transformer which fits into that place. When we design a transformer for the northeastern sector, this design is not suitable for northeastern sector because there is a problem in logistics. I cannot carry that transformer to the northeastern sector because there is a load carrying restriction in the northeastern sector. So there is no standardization kind of thing that whatever we design here is suitable for the other place also. So this is the beauty of the all technical products. So we have to keep in this mind that while designing the transform of any product, we have to need the what is the near site conditions are there. So that our engineering starts from there. So keep on asking questions. I may not be answered. So This is the most escape route I have seen in every seminar. The speaker does not have all the solutions, but they say, give me the question, I will come back. And I have my phone number and mobile in this thing. They come back after discussion with them. Since I will try to answer as maximum as possible, but I have not gone into the details of designing in totality, but I have touched upon it. From that, ultimately the user's point of view, I have taken this one. Next. Transformer is a static product. It does not rotate, there is no moving part, nothing, except for that fans and all this thing which cools the transformer. Those are the auxiliaries and additional things. But basically, transformer is a static device. It transforms electrical energy from one alternating current source to other one AC circuit, either by increasing the voltage, that is called stepping up, or by stepping it down. There are two types of transformers: step up transformers or step down transformers. Remember, reducing the voltage we are doing, but keeping the frequency same. While stepping up or stepping down, the frequency remains the same. There is step up and stepping down transformer. So electrical energy gets transformed to an electrical energy. It is not like that motor. Motor is that there are also a primary and secondary windings, but their electrical energy is transformed to mechanical energy. So here, transformer is transforming the electrical power into again to electrical power in different voltage, but frequency remains the same. But there are other transformers also, there is special use. I am not going to touch upon that because that will be very complicated for that. It is very depending on the drive, those transformers are used. Next. When I started dealing with transformer, I find it is something like a human body. Now, if you analyze this, why I call this, you will find very interesting things. Why transformer is like a human body? Just see the next slide. It breathes through the breather. It has got a breather. The air goes to the breather and it transformer starts breathing. This called there is a breather. That's why this instrument called breather. So we also breathe, transformer also breathes. Gases forms in the body like human being and get detected by the Mucosa relay. Now this, when we accumulate gas inside our body, we might fall sick similarly. So whatever the gases forms inside the transformer, that has to be detected. So there is an instrument called Mucosa relay. It oil circulates like bloodstream, like human body. It goes through the core and winding, each and every corner, and oil goes like our blood, your blood, and cools the transformers. Similarly, our blood also goes to the heart and again pumps back out. So this thing is similar to the human body. Next. It falls sick. Transformer falls sick, and it gives signal. There are so many attachments are there where it says it denotes that transformer is not working well. It is not healthy. There's some problem inside it, like our soul. It vomits through explosion vent, like human body. When there is a gas inside, the extra gas gets out from that is called the explosion vent, and there is a instrument attached to it so that additional pressure gets equalized. So it starts working well. But if it is serious, then you have to attend to it. So it is like our human body. Now, our body temperature also rises because of some malfunction, and like this, if any malfunction happens to transformer, its temperature also starts rising, and that can be detected like temperature meter, thermometer like us. It is also oil temperature indicator. Oil temperature we can measure to that instrument, as well as the winding temperature indicator. And finally, it dies when it core and winding fails. We call the transformer as dead. Now, these transformers, like human body, if it heart fails, we call that winding is the heart of the transformer. Now, we do not call a serious problem until unless that transformer winding fails. Other all these problems, we can make an attempt to do it at the site, but if the winding fails, then it has to be brought back to the manufacturing unit. Because that heart fails, you have to rework on that winding itself. Now, if you go back to history, we see In 1885, ZBD, the modern generation transformers, was invented by 3 Hungarian engineers: Karoli Jipersky, Otto Bradley, and Mikas Bay. The ZBD is from the titles. This form first come as the industrial transformer comes into this one, the ZBD model. So the fundamental theory of transformers is governed by these two fundamental laws. That is Lenz's law as well as the Faraday's law. I don't want to elaborate because you know better than this. I don't know that much. We have lost this touch. So these two laws basically govern is the fundamental law of transformers. So whatever the design, and it is a very simple design. You must have seen in this millennium, new millennium, AI, and all this kind of development in the science. Lot of developments have taken place in lot of products, but transformers remains as it is been designed. It is a U1 by N1 is equal to E2 by N2. U1 N2 is equal to this ampere turn balance is the fundamental law is still governing the transformer. So there is no change in that. Balance, whatever has been developed for transformers, it is accessories, it is protection device, it is monitoring device, but electrical design remains same. So it is a very, very crucial this thing that electrically transformer has not much changed. Next. Fundamentally, this is very simple. This is the circuit in electrical. To inductive coil, you pass this apply alternate source of voltage. It will induce in the secondary side, and the flux will this thing. But in this formation, if you only use the electrical circuit, is the induced voltage will be very, very low, very, very weak, because it has to be coupled with that steel, where permeability and all these things are to be connected in the circuit. So if we see the next slide, next. Alternating current induces magnetic flux, which is induces in EMF, electromagnetic force. However, this EMF is very weak in nature. To induce large magnitude of secondary current, we need steel. It is a very, very special steel. It is not the standard steel what we manufacture, commercial steel or that. Steel produces flux of very low reluctance path. Like a very low resistance, it is the like your electrical current flows to the this resistance path. Similarly, flux goes to the low reluctance path, that is to the steel. Now that combination becomes this. So this is the steel frame. If you want this wire and you apply voltage over here, you will get more flux accumulation because of the low reluctance path, and it will induce more secondary voltage. So this way the transformer design has been developed. Fundamentally, it has been developed over here. So this is the basic fundamental design of transformer, and you see all the flux is not leaking to the secondary coil, and there is some leakage also. So that's why there is a loss in transformers. That is the main thing why people are so much of putting their head brain to reduce this one. So there are so many development is going on to make the maximum flux linkage with this kind of thing. So a lot of development is going on, and it is a combination of electrical energy, it is electrical engineering, it is a combination of metallurgical engineering, it is a combination of thermal engineering, it is a combination of mechanical engineering. All this put together. Interestingly, this transformer is having the only machine in the world which gives 99 plus, even 99.5% efficiency. But still, we are working on it because the only reason our transmission loss in India is very, very high. It was something like 19% once upon a time. Now it has been reduced to level to 12%. But in the Western world, developed world, it is in single digit 6 to 7%. So all our energy, what has been generated from the powerhouse, to transmit it, to get to our place, to industry, get lost while transmission. So we are not able to control that losses. So we are trying to control transformer losses, because the loading on transformers is not uniform. Sometimes it goes weaker, no load loss, and something like during peak time, it also consumes a lot of energy. So we always concentrate on this. We try to say, see, when a transformer is not running on load, during no load or load, so their losses is minimum. So we try to invent some kind of metallurgical development in developing this steel so that it no loss when it is not working fully, so it is minimum in nature. So that is the engineering is still going on to find out that particular steel which will give you minimum losses. Sometimes we have gone not only to the steel, it has gone another common alloy metal that is called amorphous, which gives low no loss. So even transformer does not work, it will consume less loss. So that was the fundamental of it, how to reduce the losses. Because our losses of transmission is very, very costly. Now basically it's a core and winding. Core is steel, winding is copper, but still now development is going on. Core is CRGO, this is a special steel. Here the metallurgy comes into picture. CRGO is cold rolled grain oriented. Whatever the metallurgy involved in the steel is a particular grain formation. So when this steel will produce, flux will go through that, it will consume less power, less losses, it will deliver less losses, and gives maximum efficiency, what is possible, and in self-consumption of the transformer will be minimum. And next generation is that amorphous. Amorphous has not yet still come that way, that big way. It is basically the alloy steels, the CRGO, and amorphous is that it is not steel, it is some other material. So there, amorphous is not being used for the large transformers, but small transformer, distribution transformer, it is still now being tried out, and some electricity board where small transformer distribution there amorphous metal is used. It is not yet that successful, I must say, for the industrial purpose use, but still there are quite a lot of uses going on. Earlier this CRGO, there is one more steel that HRGO, so that is not used for transformer. Now what steel we use for motors, it is not, so that is CRNO, that is cold rolled non-oriented, non-grain oriented. You don't need to have that particular grain formation in that particular metallurgy requirement is not there required in the motors or fans or whatever we are using here. That is CRNO steel. Interesting point is that India is having not less than 1,500 transformer manufacturers, but not a single gram CRGO is manufactured. That is the very, very interesting point. We manufacture 350, 1200 kV transformers. We are the number one in the world in transmission voltage. 1200 kV we transmit. China highest level voltage level is 1165. Where India produces, they have Bina Bina substation there, 1200 kV voltage is being stepped down. So India is the number one in that field.
Where from this CRGO comes?
I'm coming to that. CRGO is only source is that your developed countries like France, America, Russia was one of them. This thing, but Russia's CRGO is now seems to have developed to the next grade of this thing, low loss transformers. Russian CRGO is not discarded, but still a lot of uses are there. Then Germany, Nippon is in Japan. So there is a hardly 7 or 8, at the most 10. It can be counted in one single finger. So only this is the source. Now you see the challenge of the transformer manufacturers. I don't have my raw material. There is a demand from the market. So I have to design based on the raw materials available. I am not going the standard 100% efficient transformer I can design, but I will not get those materials in hand. So this is a big challenge for all the transformer manufacturers to get the materials. And second is that your copper. Now this copper is also very interesting copper. It is a 99.9%, 99.99% conductive copper. So that gives the your continuity of this copper is to be seen. So these two are the main resources that, and they are also your suppliers are very vendors are very limited.
Can I add one thing here?
Sure.
For mining actually, because this hematite and magnetite is the having your large quantity of blue dust in iron. If there is less amount of blue dust, then it is not suitable for pig iron making. If it is not suitable for pig iron making, then it will not give you the good steel. So that percentage is very, very not available in our Indian context in the iron ore mines. So that's why this CRGO possibly, I'm just linking it. So that's why may not be available in this intermediate.
I will just elaborate on this thing. Once I had a discussion with Tata Steel and Jindal also, they are pressing hard for very, very special transformer for us. And for that, we have to import only from Nippon, the number one. I told them I can give you this transformer, provided you give me 1 gram of steel from you are so big steel manufacturers. I give you the history of that. In the early 90s, Mekon, our sale, RSP, first tried this to make this one with the help of Mekon or even those two. They tried to make our this thing, CRGO steel, but it was not commercially viable. The yield was 8%. So it was rejected. After that, nobody tried that. Now, Jindal is promising their CRGO plant will come. I don't know how long or when, but still such time. But ThyssenKrupp Germany has already opened their plant in Nasik, but that is for cutting and sizing. They bring the spool and then cut and size as per the manufacturer's requirement. So these are the challenges because of that. Similarly, this Hindustan Copper, so much of copper manufacturer, big manufacturer, they don't produce this copper for transformers. That is for your conductors and all these things, cables. Here comes from the Birla Copper, and Birla Copper is now also in the problem in the pollution creation along with this issue. So we are basically dependent on single source sometimes multiple source, 1 or 2 like that. So this is a challenge to all the transformer manufacturers. Now, just 1 minute. Come back. So to come out that copper, now aluminium is being tried. Now aluminium conductivity is less than copper, but if we increase the surface area, then what happens? We get the same condition. So aluminium foil is now being tried, and it is very, very successful. So now in distribution sector, I'm not talking about large transformers. In distribution, up to 5, 7 MVA and 10 MVA station transformers, we have gone for aluminium foil. Now copper foil has also come. Is coming. This is the next generation, but aluminum foil has been standardized. Now all the solar transformers which is withstanding all these things, your lot of harmonics are there and all these things, they are being tried with aluminum foil. It is very, very successful. So aluminum is a next generation. What we used to discard aluminum, the conductivity is low. Now aluminum is coming in the foil form. Next.
So what about that brittleness issue of that aluminum?
That has been anodized. Some treatment is there with aluminium, manufacturers are coming with that. Anodized is coming, and these are now being proven. After that,
differential expansion contract.
All
yes. But that is due to
anodization. And there is an aluminium foil transformer first with the Westinghouse. Crompton is tried in the market. That was had an insulation is also that diamond epoxy paper on the aluminum foil itself. And their oil is to go to those capillaries. When you paste it like that and their diamond papers, oil is to go and cool it properly. So whatever the extra heating that is to be taken care by the additional this thing to each and every coil. So these are the specialized this thing has been done. So those things are now successful, and the short circuit withstand capacity has also been increased because coil formation it reduces the axial force is okay, but radial force they negative. If we go for analyzing this thing, going to the short circuit, the mechanical force experienced by the transformers, they I think they nullify this one. When you just bifurcate that axial force in the 2 direction, one is radial, one is the this thing, then we find that axial force short circuit withstand capacity is much more in the aluminum foil of transformers
compared to
but if you go for foil, not for conductor. The copper is problem is that it is very difficult to bend, but that try is going on in a smaller range. It will come and the next 10, 15 years it will be copper foil will see what accepted. Now to design a perfect transformer, 100% efficient transformer can be designed. That if you have perfect electromagnetic coupling, so you get a good steel, perfect voltage regulation. Interesting point is that we try to figure, I must say that should not use that word, but I will try to finger a most safest product that is transformer. We cannot, you see, when we started my engineering from college to industry, I first stepped in. Those days, all the consultants, I'm talking about the here since I'm in Calcutta, all the big consultant specification, DCPF, even those who make all, if you look at that, you will see the product should be variable, product should be suitable for 6% voltage variation, 3% frequency variation, 5%, 3% sequence variation, and 3% combined variation. This is the standardization of their all specification. But unfortunately, our system voltage is so fluctuating. All these specification has changed to 10, 5, 10. 10% voltage variation, 10% this variation, 5% combined variation. Now they are. We are not able to feed quality power to the product, and we are making the product most difficult one to design. So that is the scenario as of today. So thinking that all this I have to take care during my design. So perfect sinusoidal waveform during the excitation of the voltage wave mobile and no loss. More I can reduce the loss, transformer efficiency will go up. For that we need good steel, conductor losses, different conductors, coil and something, new generation if can't come, so you can reduce the loss. But we are concentrating on that. Now core type, that winding surrounds the core. There are two types of core normally in transformer design. The most popular is here. The transformer preferred core is the core type construction. It is easier to manufacture from the manufacturer point of view and easier to maintain the repair point of view and users friendly. So easier to manufacture and cooling is better. Here the capillaries, when we wind the winding, every nook and corner so that the oil can flow and it can cool the transformer, otherwise the transformer will get unnecessary heat. So all this point of view, it is better to use core type and maintenance and repairs are easy. But shell type transformers normally they are very rare, small use, and special transformers in that case, the shell type formation is there. So these are two basic core type of we use in this transformer. Again, next. So this is the core construction, very simple. Here the one source, high voltage, one is the secondary, primary and secondary, and this is the core. Now shell type is like this. Next. This is the shell type, where primary and secondary come out like that, and entire path is like shell. This CRGO part will be like this. So there is two window, and you can find that windings are placed one above another. So it is very not very popular until this special requirement demands that. So core type in most popular use is that core type transformers. Next. Transformer is a product. You will see that delivery is a big problem. When we ask for getting this transformer, because so much of manual labor is there. In motor, since I am from both the industries, the motor rotor has become now mechanized. So rotor rolls out with the machine. But transformer, this core building, simple core building, it is 100% manual. There is no, you have to take the CRGO and place one after another horizontally by a buttman, and you have to build it. Whatever it might be, 350 MVA transformers or whatever is this, it is the core building is manual. And after building that core, as per design, it is to be vertical. It is to be made vertical. Now next slide. This is to be the level, the core is to be made. The first thing of the transformer. Now, the two production line goes, one is go with the core and one goes with the winding. These are get synchronized when the assembly is to be made. So this goes parallel. Now core while making the core, these three limbs, this is a core type construction, three limbs are manufactured and it is clamped. Here, the core tightness is the most important thing. Because if the core is not tight properly, so that's why these clamps are attached and it make it very solid. And sometimes in big transformers, there is a taping also is being done. Now winding is also manufactured. So these two comes at one assembly point and then it is made the core coil assembly. Let's see. Next. Now let us touch upon the losses. What are the losses transformer incurs? Transformer loss, we always specify that the total loss. Now total loss is basically no load loss, which comes from core basically, and load loss. No load loss is also saying that iron loss, because of this core, whatever the current is being passed, then the iron will be consuming this thing, and then the iron loss will be there. Then it is the eddy current loss, because that circulating current starts flowing in the core material, and that gives you the eddy current effect, and that also consumes some power. Then comes the load loss. Load loss can be divided in stray losses, because wherever the junction points are there, there will be some leakage losses continuously close to the circuit. There will be leakage continuously start over there. And hysteresis loss. Hysteresis loss, the BH curve. In ideal condition, that BH curve should be followed continuously. In that, whenever you switch on the transformer, when you switch on the transformer or electromagnetic induction is taking place, that BH loop will start forming. So it has to follow the same path, but it actually does not. There is some BH loop is getting created and consumption losses. That is your hysteresis loss. Hysteresis loss is formed. Hysteresis loop is being formed in the BH curve. Then copper loss. What the winding is there, that copper loss, I square R loss that we call. That is because of current passing through the copper windings, and this gives you the copper loss. Stray losses over is due to the leakage of flux. Whenever the flux is not connecting the other secondary winding, it will be the wastage basically. So that is the stray losses. Next. Eddy current loss is due to, as I was saying, current, circulating current in each lamination what we done, steel for the core, and is directly proportional to the thickness of the core. So what we do to reduce the eddy current loss, the thickness of the core, the slit, what we know, it is a 0.27 millimeter. 0.2 to 27 millimeter, 127 millimeter, we keep it like that. And can be reduced by laminated sheet steel with less thickness, whatever is possible. But if you keep on doing the less thickness, it may not be that solid to hold that winding also. So we have to keep that in also in mind. So it is optimum level, 0.27 and all this millimeter thickness, we keep it like that. Hysteresis loss is due to the hysteresis phenomena of BH curve, as I told, can be reduced by good quality steel. So BH curve should be absolutely forwardable. I must say that it is true. Number of times that electromagnetic induction is taking place, the ideal BH curve has to form. So it will form the B and H loop. It will be always like this, form the ideal BH curve should be followed. Next. Now, stray losses of transformer happens because of this. Losses in tank due to leakage fluxes and from winding. So whatever flux is not connecting the secondary winding, it is passing through, completing some circuit, either through tank, whatever the path they nearest in the mind, fine. So you have loss in tank, losses tank due to leads. After making the windings, we connect it to the leads to a terminal box. So those leads also carry those flux and create that losses. The losses clamping to frame, where we are clamping with the nuts and bolts and all these things are completing the circuit of leakage fluxes and create that losses. Losses clamping frame due to leads, the stray losses in loaded winding. When you load the transformers, so it will be, again there will be some losses, because that leakage flux will also find some shortest path to complete that loop. Stray losses of unloaded winding. When we keep it on the open circuit condition, it is getting induced, and there are some losses will be, flux will be there, it will not be able to connect the secondary winding also. So this is like normally 6 to 7% of your load loss goes into the stray loss. So these are the wastage basically. So a lot of concentration on there, how to reduce these losses. More we reduce this wastage, we'll be able to get more efficiency of the transformer. Next. Now from the cooling point of view, cooling is the most important part of the transformer. Now when we are designing a transformer, like I said, it's a human body. So when we passing through, current is being passed and resistance is there, I square R loss is being created, and that is basically creating the heat. So that temperature starts going up. So O and AM is the oil natural, air natural. The transformers what we see, that is the oil natural normally, air natural transformers. Here oil is also a cooling medium and air is also a cooling medium. Now if it is not sufficient enough, that we need to additional power, cooling power, then fan comes into picture. That is O8AF, oil natural, air forced. So it is inducted by the fan. Now here, next generation transformers are coming, that's why we don't need oil. This is being now tried out, and up to certain MVA level, certain rating, this is very, very successful. And where the hazardous areas are there, where oil catches fire, those areas we have removed oil, and that is air natural, that is dry type transformers. There is no oil. So they are also use fans for cooling it down. Then oil natural, water forced. There are some special use of transformers, that water pumps are there to cool the transformers. OFWF, oil forced, water forced. Oil is also forced to pump, water is also forced to the pump. So these are the nomenclature given in IIEST standards, where we all the uses of transformers also nomenclature is like this. OFAF, oil forced, air forced. These are all as per IIEST 2026, that is the mother specification for transformer oil field transformers. Next. This is the elaborative this is the sketch of a transformer, how it looks like. These are radiators. These are the cooling radiators. This is conservator where the oil is filled up, and this is the explosion vent. If the pressure goes into the tank, the oil comes through. Now this is the problem is that now these are also being important thing, that once the pressure develop inside the transformer, there is a membrane is there, aluminum foil or something like that, which can, if the pressure goes more than 5 psi, it gets ruptured and extra pressure oil comes out. Now once it gets ruptured, the transformer has to be again taken to service to put that membrane again. So transformer go out of service. So nowadays the second generation thing is gamma, that is the pressure relief valve. So if extra pressure gets up, instead of explosion vent, we give pressure relief valve, so that extra pressure goes out, the oil goes out, and it gets re-spitted accordingly. If it is not, there's something very, very abnormal. Then this is the tank. This is the rating place is there, details of the transformer. Then these are the lifting last, then transformer radiator fins are there. These are very, very thin, so that the cooling can be done. It radiates heat to the outside ambient and cools the oil, and it goes back. The natural convection takes place and cools down the transformer winding. Next. And this is the oil natural, air forced. These are the fans are there. So these fans are basically cools the radiator, and the temperature are under control within the specified limit. Next. These are the few relevant IIEST. I am talking about the Indian IIEST, Indian standards. These are the guiding factor for manufacturing transformers and to follow. IIEST 20 is the specification for oil field transformers. Now, many people ask, if I overload the transformers, then what will happen? Suppose one transformer fails, other transformers, I have to take the additional load. This is a very, very dangerous and very, very minutely look into that. There is a guiding factor of overloading of transformer, that is IIEST 6600. Transformer is supposed to deliver all these guaranteed parameters under this one, specified conditions and specified testing. Overloading is not allowed, but sometimes we are bound to overload the transformers. Now this overload factor is guided here with the details. We have to find out how much overloading we are going to give for transformers. It says every overloading, if you overload the transformer, say 20% or 30% like that, the life of insulation comes by drastically. The insulation failure takes place. So to get the mean average of that, if you run the transformer 10% overloading, there's also a limit 10 to 20% overloading. You have to underload the transformer during this 24 hours operation to regain the life of the instrument. So by plotting how much overloading you are doing and how much underloading you are doing, you get a K factor. That is governing factor of how much overloading we can go by this. But if as per transformer IES, overloading is not allowed. That's why all transformers, when it is been rating is designed, people overload up to 80%, 75%, like that. So in case of overloading comes this thing, and then also have some load sharing. So other transformers are also kept in standby by load sharing method, so they can distribute the load. Overloading in transformer on continuous basis is not allowed. It will ultimately ruin the transformer.
Basically, you over-design the transformer.
If you want to, this basically I designed 10 MVA and declare it 8 MVA. That is different issue. But if I design a 10 MVA, it is not allowed to take even 11 MVA or even like that. But if I for emergency purpose, I have to lead on instantaneous, sometime. Again, you have to underload between the 24 hours operation, 90% overloading, 80% to irrigate the life of the installation. IS 10028, maintenance of the transformer. How to maintain a transformer. Now, transformer oil is very, very interesting subject. It is a subject by itself of transformers. That's why you find there are two ISs there. One is transformer oil. It is a new oil. That means when you buy oil, here also interesting point is that in India, for 1,500 plus transformer manufacturers, there are only two transformer oils. You will not believe it. Upper and Savita. Just imagine how the transformer manufacturer running around to get the supply from them. Even Indian oil, now they have started, but still yet to be established accepted by the industries and all. So these are the two. This is crude is imported, they process in their plant, and this transformer oil is supplied to the transformer manufacturers. This is imported crude. Okay. So that is for the new oil. It comes in seal drum. Now breakdown voltage. Transformer oil serves two purposes. First purpose is that cooling. Definitely, it takes the heat generated in the winding, it absorbs heat, it goes to the radiator, get dissipated, natural phenomena convection method, and cold oil goes into that. So this circulation is going on. But it also serves one more purpose, that is insulation. So transformer oil is the most interesting subject by itself. That's why there is two distinct. IS 1866, that's the maintenance of transformer oil. How to maintain transformer. It is separate IS for that. Then IS 11171, that is specification for dry gauge transformers. How to use, how to design, what precautions to be taken for dry gauge transformers. Now, transformer oil, there is a breakdown voltage. We test for it. So breakdown voltage in whatever is required for the transformer, when we buy new oil, it is less. We demand 60 kV peak. That at 60 kV peak, that it will rupture, it will not lose its insulation. But when we buy new oil, we don't get more than 35 to 40 kV. We have to filter that out. This is the mistakes made by the users. They think that I have got transformer oil in sealed drums, new directly from supplier, I can mix them and run these drums. This never should be. Even the new oil has to be filtered. So that this is a very, very interesting subject that all the people, there's a I have got a new oil, so let us use it. It should not be. Next. Windings are different for different purpose of use. Spiral, low voltage, medium current, and tertiary. There is a 3 winding transformers also. The tertiary winding they call it. So there normally spiral winding is used. Spiral is the most simple winding. We got when this way. Then helical winding, where high current and low voltage. This is the LV normally generator transformers, where generating basically all generator transformer normally 11 kV, 3.3 kV, 6.6 kV voltage is generated by the turbine and this one generator, and then it is stepped up. So those DT is getting low voltage and stepping up. So those transformers are basically helical winding is useful. Is reverse section winding is 132 special low current. There's a combination. It is not particularly. It is that depends on the manufacturer's, I must say, the capability. What kind of designs there is, because in India there are so many varieties of transformers manufactured, different ranges. Some transformer manufacturers from 5 kV up to say 15 MVA. So their design is standardized with their standard supplies and all this thing is standardized somewhat. The transformer manufacturer who is minimum rating is 10 MVA to 100 MVA. So they are also standardized something. It is not like that I can manufacture a design is there, I can use that. It is depends on the manufacturer's comfort and what standardization they have adopted. So those who are manufacturing 500 MVA transformers, their standardization is also something different depending on their supplies and their design availability. So this is a very critical. So many combinations are there in transformer industries. It's very difficult to standardize. An interesting one more point I can tell you, since I told you that I'm from motor industry, my design and all initially. Induction motor, they have standardized IS 325 from mechanical point of view. Once you say that it is shaft 325L, 350L, all your mechanical data is frozen. You cannot touch. Your shaft diameter is fixed, your shaft length is fixed, grouting bolt is fixed, dimension total is fixed. Your mechanically it is standard. You cannot touch that. 315L, it is basically the rotor length. 350 depending on that, frame size is different. And accordingly, how much power it will be the output, it is decided. So it is designed standardized from the mechanical point of view. But unfortunately, in transformer, it is standardized from KVA side, electrical side. So mechanically, it is free for all. It is WWF. You can design any damn mechanical things. Somebody wants cable from the bottom, somebody wants cable from the top, somebody wants buster, somebody wants this. They are pushing, somebody wants this, that, this accessories. So your transformer, each and every drawing is to be prepared separately, depending on the specification. So that is very unfortunate. In India, there is no standardization. There are so many electricity boards and all these things. If you see, their transmission board is different. Now, most interesting point is our chicken neck in West Bengal. Experts say there is enough power in our northeastern sector, high level, and also, but we have problems in evacuating that from there, and we have evacuated through that only chicken neck available, Shibpur and that path. So PGCL working on that, standardizing on that. There's a 132 kV available, and so many voltage classes are available. Before this national grid, we had so many this thing. 66 kV, somebody is transmitting, somebody is 110 kV, somebody is 132 kV, somebody is 220 kV, 765 kV DC. So many these things are there. So every state, your electricity board is having different specifications. So all the transformer manufacturer cannot standardize anything. It depends on the what is coming to them. And KVA is the transformer rating is not decided by the transformer manufacturers. You only know your consumption of load. That you have to decide. Your project, what is consumption, what kind of load it is, inductive load, capacitive load, there is a harmonics are there or not. Now if you go to any steel plant, I must say to all the young engineers, if you get opportunity, visit a steel plant. All kinds of, in power plant, there is also some standardization. You can get this kind of drives. But in steel plant, different varieties of loads are there. Some are Italian drives, some are German drives, some are Russian drives. Because one plant is we got the technology from one countries. So all the drives are different. Somebody is having 19th harmonic, somebody Italian. Nobody wants today. All those things have lost their life also. But still there is a running, and to provide power for those drives is very difficult to design transformers. So what kind of consumption is there for those drives, and variety of roller table motors? How many number of starts and stops, and reverse drive? The motor is rotating. So those hot this thing, your rails are going, it's coming back again. This shape again is going to check the next channel. So these are the beautiful, I must exposure to the students if they visit one steel plant. Fortunately, in 1980 to 85, I was given your assignment for Crompton Greaves. Crompton is a multi-product. They have contactors, they have breakers, they have HT breakers, they have panels, they have motors, they have transformers, everything. So when Rajiv Gandhi first sanctioned money for this steel plants, modernization of steel plant, I was given an assignment to get the approval of all those products in a steel plant. Say somebody is Mekon, somebody is Emendoscoop, then CET came into picture, Center of Engineering and Technology, they took that one. So everybody's decision is different. To suit that product for that specification for a steel plant is a task by itself. So steel plant I consider depending on my exposure is an ideal place for any electrical engineer or mechanical engineer or metallurgy engineer. It is a place, it is a real heaven. I have not seen any multi-use of product in transformer, industry, any other industry. They have all standardized something like that. But steel plant has wide variety. Every steel plant is also different because technology came from different countries. So these are the typical winding depending on the use of the product at place. What kind of uses are there? Next. Here's typical spiral winding. This is the winding is being done. It is also clamped. Now this winding then put into those core. I have shown you the core. Now how to open the core then? Core is already built. Now top portion, next slide. Now top core, this is the core already built. The winding has come. Now you have to open the upper clamp. That is called yoke. This yoke is opened up. Then all those limbs are to be put inside that. And again to be clamped. The yoke is to be put and then the core coil assembly will be made. Next slide. This becomes a core coil assembly. Now this goes into transformer insulation. We'll be coming to that, but here I just touch upon. Transformer is the most poorest of the poor. First grade of insulation is used in transformer. That is classic. We have the A, B, F, H, C. These are the different insulation levels. Transformer is the most lower grade of all field transformers, having the most lower grade of insulation, that is class A insulation. Now these insulations are non-hygroscopic. It absorbs moisture from outside. Now, so it is to be dried because if moisture is there, it is something like you are accumulated water in your lungs. So it has to be dried out, extracted out. So it goes to the oven. Now every KV class has a particular cycle of this heating and under pressure and heating this cycle goes on. So that is to be maintained for 36 hours, 48 hours depending on that. So it goes to the oven and entire moisture is taken out. You will not believe when this core is made ready on the oven, we get buckets full of water. Why we cannot imagine that so much of moisture is absorbed by this. Until it is dried, this cannot be used. So it goes to the cycle, pressure and heat. This cycle is followed. This IS cycle is defined. I'm not going to touch on that. Every insulation grade, every voltage class, there is cycle is defined. You have to continuously run that cycle. Next. This is a fundamental equation while designing transformer. Everybody knows about it. I have forgotten just for this lecture. I have copied it down from somewhere. So EMF force is that 4.44 flux density, area of cross section, and frequency. Flux density is the maximum flux density in Tesla. This is for the core. What flux density? A is the net cross section area of the core. That is the pi d square by 4. You can see. Yeah, after fixing core area from there, because E, you know what excitation voltage you are going to give. You know because your consumer is telling you I want 1000 kVA at 33 by 11. So you know the details of input. From there you derive whatever force is there, and there you find out the voltage per turn. That is the first thing the designer has to find out, voltage per turn. That will give you the number of turns because U1 by E2 by E2, that formula is to be balanced out. So voltage per turn is the only the designer has to find out from the input of the consumer customer has given or the specification equally has come. Next. If you know the desired primary and secondary voltage and Bessel turns ratio, we can calculate the voltage by number of primary turns. So primary turns and all we can find out, and the designer starts working on that. Very simple design of that. Now nobody designs nowadays, it is only feedback this one, and computer gives you the most optimum design available. Now in that most optimum things we have done, then the designer will start seeing whether other conditions specifications are met or not. Computer gives you the optimum design, but customer has said my maximum efficiency should occur at my 75% load. Normally maximum efficiency occurs when your no load is equal to your full load condition. So this equation is, that is an ideal condition. That never happens. So your transformer size will be more. So this optimum design has to be always matched with the other specification. Then in redesigning starts. Give it another input. Next. Calculate phase current root 3. That one. Then current density, the selection depends on what type of engine you are using, load loss, temperature rise, what. Your IES gives you the guidelines that oil filled transformer, when it runs on full load, the oil temperature should not go more than 50 degrees centigrade, and winding temperature is the actual, your temperature starts rising. Clear? Then it should be 55 degrees. But for the safer use, every consultant, every user keeps it down 5 to 10 degrees lower. So we get inquiries, not as per IS, stringent than IS, then it should be 45 to 50 and 50. So all these our homework will get lost. We have to design it. What is the temperature required by transformer? So even if you have all the data, I can run I just click of a button, I can take out the transformer design, but it's not allowed because these conditions have been specified by that. So these are the intricacies why transformer design. That's why a designer is required. Otherwise, AI would have done it. Now I don't know when AI will come, and that part also be completed. I think a lot of what will happen we don't know, of course. But these kind of things will be now looked by the. You see in the I was talking to some of my young IT guys when they prepared their biodata. I said, when we used to write our biodata, we had to give it in different format, this much of training and all these things we have done, so much of exposure in that this one. They said, no, that is not required nowadays. But why? I just curious, why? They said we want keywords. Because nowadays, my biodata is shortlisted by the AI. So those keywords must be there in my biodata. So those who are preparing for that, do not standardize your biodata. And this is my input to you all. Specific biodata to be prepared for specific interview. What is that product? What is they want? What they want? Because those keywords, because this is now being picked up by the computer, and only they are selected. Although you are a deserving candidate, but you will not get the call because those keywords are not there. So nowadays, new business has started. Those who manufacture biodata, you approach them, they will give you biodata depending upon the job. So very interesting. That's what I'm saying. So all these things you can relate with the designing also. So we have to see what is to be customer wants and what is to be put in the design. Now current density. I tell you, you want this is a very interesting subject of industrial product and the consumer product. When you go to buy a TV, it's simple. You want this 36 inch, and they tell you the features. These are available. You choose among them. Here industrial, they give you the specification. You have to switch to that. This opposite. And here, everybody wants an ideal things. So they put so many things. But it has to be also economical. That's one part. So current density, when I am able to design a transformer with that specified loss, specified temperature rise of a particular customer, then why customer should be bothered about my current density? Now they also specify me the current. They tie my hands, legs, brain, everything together. and I have to design a transformer. Sometimes I tell them, I give you the raw material, you better design a transformer. If you do not allow me, do not give me the room to play, how can I design a transformer when you are specifying everything? But your requirement is that for this project, you need a transformer should work lifetime, say 25 years, 30 years, this much of loss, this much of temperature rise, what is specification is there. But who are you to dictate me in my design? So these are the pressure on the transformer manufacturers. And still we have, because customer is my first general manager told me customer is always right because he has got money. So we follow that. Yes, I'll give you. So we lower the current density. Lower current density means copper. If I increase the current density, then I will using the circumference of the copper conductor maximum. Current these things will flow through that almost the surface area. But they are restricting me with the less, that means the copper conduction will be 30% or 40% of use. Balance is wastage. Wastage means I may see ignorance factor or whatever we say, it is for the preventive maintenance these things. Because earlier I used to say that GC used to give me this much big fan, so much of weight, the Russian technology, they go by the weight. So this much of weight of the transformer. So reduce the copper weight, then I can give him, but if I use a higher current density, then higher load loss, higher temperature gradient. Now temperature gradient is very interesting. Your 50-degree temperature might be your optimum point, but your lowest temperature, there also a gradient. You cannot keep 10 degrees like that. Your coldest point and the hottest point should not be more than 4 to 5 degrees. So that way you have to design also. So not only final things, entire things. So these are the basically. There of course there is a reason. Reason is that transformer should be healthy enough. There should not be any hotspot somewhere, something it will be developed and it will spoil that insulation. So reduce copper weight results lower core dimension, reduction of core weight, and lower load loss. So these are the advantage and disadvantage both we have to play within your design. Next. Weight of conductor, we can find it out from the density of copper is standard, cross section, and number of turns. Load loss is I square R plus strain loss, these are together. Copper loss depends on resistivity, strain loss depends on leakage loss. This we have already covered in that. So these are the basic design factor parameters we have to consider while designing a transformer. Next. Out of all the machines, I must say transformer is the most robust, dependable electrical machine. If properly designed with good quality raw materials, followed by required checks and measures during manufacturing and testing, maintained during service as per the required standards, it can give trouble-free life throughout its life. I have seen transformers which have not been given any trouble during its 25 years of life. Average, but still you will find in this thing, Russian transformers are working 40 years past and all this. But there is one interesting subject is here. There is a joke in international market of CRGO. India consumes more than the CRGO jointly manufactured by all the CRGO manufacturers. This is a joke in international market because secondary material is plenty in Indian market. Once I went to Tata Steel, I found there is a big queue in front of the gate. Just out of curiosity, asked me what is this there? Scrap dealers have come to buy the 1940 transformers that is being scrapped by Tata Steel. What is they will do with that one? They will cut and size 40 MVA that core, and jolly well they can make 50 MVA transformer from there. They will redraw the copper. The copper might not be having 99.9% conductivity, but still that winding could be made. They will reprocess the oil. Oil will be having BDB value, breakdown voltage 60 kV they will get, but the chemistry of the oil will change, that the insulation property will go. So this is India. You have to live with it, you have to compete with it, and still you have to run your company. So these are the challenges we face as a transformer manufacturers, but still it is a very, very beautiful product. Now, what I was saying, the transformer is not only the electrical product, it is the combination of electrical, it is a combination of metallurgy, it is a combination of mechanical, it is a combination of thermal. transformer faces three kind of stress. One is an electrical stress. Suppose some short circuits are taking place. There is an electrical stress develops that goes into the mechanical stress. There's whatever the tie up and all this thing done that will break. And temperature will go up. So there is a thermal design also involved. So one electrical designer cannot complete one transformer design. In our design team, we have every design engineer from every field. So transformer is a heaven. Transformer industry is a heaven for all the engineers, I must say. Variety of engineers, variety of experience, variety of coming to picture here. So you have to calculate how much heat is dissipated, how much mechanical force is experiencing because of electrical loss, stress and all. So all these are combined in transformer. And it is being taught by electrical department, of course. So that is a very interesting. Now, when we are basic information required when you design it, as I said, transformer manufacturers do not decide the rating of the transformers. Because transformer users, they know what is the load of this one. Here AC is running, lift is running. So lift motor is there, so many starts and stops, so many reverse direction, so many things are placed in place. Somewhere some abnormal phenomena is taking place. That, so all these have to be calculated and load requirement is to be taken care of. What is the inductive load? What is the capacitive load? So all these things are based on that the transformer rating is decided and by the consultant or by the project manager or obviously the users of the thing. They give us the rating. We have nothing to pay. They people sometimes they tell us, I said we are not the transformer ratings. We are not the project designers. You have to tell us what you want. Or if you want us to take the number, then you have to be a project consultant. So getting and missing and what is your voltage, you only know. We don't know. Whether you are getting supply from 33 kV or 132 kV, 220 kV, all these details minimum we need. Now cappings, I was telling, we do not get quality power by transmission. So there is always a fluctuation in that. So every fluctuation, transformer should not trip over voltage, under voltage. So transformer should be allowed to function with those variation of voltage. Right now I am getting 33 kV, it is going down to 31.5 kV, it is going up to 36 kV. During peak season, summer, winter, a lot of things takes place. So transformer should be, the tapping rings are there, tapping windings are there. The separatory tap winding will give you to get the output continuously. Suppose it is 132 by 33, output should be 33. Whatever the 132 kV comes to you, whether it is 135, 131, it doesn't matter. With this tapping correction, you have to get the 33 kV smooth. There should not be any disturbance. So that's why this compensated, this is also other way, the compensated winding. When voltage goes up, we take out the turns from the circuit, and when voltage goes down, we add number of turns in the circuit. So this is a phenomena. This can be done manually, this can be done automatically. So this is called off-circuit and tappings and on-load tappings. During transformer running, there is a mechanism called on-load tap changer. It starts playing the taps depending on the voltage fluctuation. The steps of 1.25% or 5%, whatever the setting required by them. And off-circuit, you have to. Here is a misnomer. Many learned engineers in many industries misunderstand that off-circuit and off-load stuff. I have seen in my, I should not name, in my company working somewhere, my maintenance engineer made blunder and transformer got blasted. Off-circuit and off-load is not same. Off-circuit means, these are off-circuit tapping. Off-circuit tapping means you have to know energization. That means both the sides, HT and LT, both have to be taken out. And then only you can take. I think you were telling about that residual voltage and all these things are happening, stays there, and sir told you to take out that using like that. So when we are doing offload, that means I am taking the load side off. High voltage is there. It is already have an induction effect. So current is already there in the LP1. At that point of time, if I want to change the tapping, just blast there. So that is on load. That is not allowed. So it is off circuit. So off circuit is the word people misunderstand the off load. is not. Both the sides should be energized. Next. States like this, winding connection, vector group, these are the vector group formation. So GT, these vector group have very, very specific requirement for specific purpose, like that delta star, secondary star, primary delta. Because of this generation, you have you're synchronized with the connecting transformers or switch here. So these vector group has to be matched. So these are in the list. There are so many vector groups are there, but delta star, star delta, these are the most this one. Apart from that, for grounding purpose, there is a zigzag winding. The zigzag vector group is also there. When we want to ground the earthing for purpose, we use it so that there is a lot of circulating current takes place in the right different type of loads. That goes needs to be earth, and for that special purpose the transformer used. Then ambient temperature, ambient rise over the ambient temperature, degree centigrade, insulation class, altitude. Altitude is also main factor. We have supplied transformer to your Ladakh, where the ambient itself during this thing it goes up to minus 25 degrees centigrade. So you don't expect that thing. So we use special type of oil. Normal oil, I said cheap fuel, there is a basically your paraffin based oil. So that gets some this cooling effect, and this it is not more than that. So we use naphtha based oil. So there also a separate kind of oil that they are prescribed for this particular altitudes. Next, cooling oil and then termination. Somebody wants cable box, somebody wants bare bushing, terminal box. Any other specific requirement by percentage impedance. This percentage impedance is a very, very important one part. It is a resistance plus reactance of the total winding. This percentage impedance is basically gives you the short circuit capacity, withstand capacity of the transformer. If dead short circuit takes place in the terminal winding, this percentage rate will offer that that short circuit current to restrict that short circuit current to flow. So here also tertiary winding comes into picture that bypass that load. So many these things. So percentage impedance is also very much required. Also for load sharing purpose. If two transformers have to be shared load, so all these things have to be matched properly. So these are the designers who look into that this one. Next. Then these are the accessories and all these things we use: conservator, silica gel, breather. Silica gel breather, when your transformer breathes, outside air is there, that is moisture. So it goes to the silica gel, which absorbs moisture, and dry air is going to go into the oil. So oil does not get contaminated by or get moisturized. Then rollers, you can move the transformers from this direction. You have the explosion vent, cooling radiators. These are the accessories normally as per IIEST it is given, and accordingly the transformer manufacturer gives, including the transformer. Special kind of requirement of when it comes, it gets added to that. Next, oil temperature indicator and winding temperature indicator. This oil temperature indicator and winding temperature having the two contacts normally. When it goes up, suppose suddenly the control room is fine, they get the temperature is going up. So setting is done for alarm and trip purpose. It gives you alarm. You have to attend it the way the temperature is going up suddenly and rectify that fault if possible, or transformer will give tripping signal. Then transformer will stop. It will de-energize from the circuit, and it will be, because basically requirement is that transformer is the heart of power. Power shutdown is at any cost is not acceptable. So somehow everybody is focusing on the winding is not disturbed. Anything can go wrong, anything can happen with transformer leakage, anything we can take care of at the site. But failure of transformer is all protected by this, so that heart does not fail. So the transformer winding is protected. That's why all these accessories have been placed so that it can protect you. For few hours it is okay. I can rectify, I can reset the transformer and power outage is removed. But the winding is intact. To protect the winding, all this protection because is here. Then plain oil level. Oil level is the most important. The transformer has to be dipped or core and winding dipped into the oil. And then that's why the plain oil level gauge is there with the conservator. We can see how much oil is there, because during summer it comes down and in winter it goes up because of the breathing of the transformer, pressure in the transformer. A lot of things are there. There is a magnetic oil level gauge also, additional protection, so that if it goes down suddenly, it gives you the alarm. Next. So these are the design flux density, finalize the core design, then select current density, finalize the copper. All these things are done. Turns ratio calculation, secondary number of turns, all these things are being done that we discussed. We can go to the next slide. Total iron loss, copper loss has been designed. Calculate torque rate. Now this is the one. Calculate heat dissipation. Here the thermal engineering comes into picture. How much heat is generated by the transformer without cooling? First, we have to find out the heat generation is generated by the transformer itself. Then only we can give you the cooling system. This will be cooled. Oil quantity is to be decided. Radiator number of fins have to be decided. Number of radiators has to be decided. All comes from this calculation of heat dissipation. Okay. Then finally, mechanism design, tank, radiators, core, all these things. The transformer accessory and protection devices are also there, like OTI, WTI, all these things. Decide exciting parameters based on design criteria. Next, quickly. Here you have to also keep in mind the transportation limitation. Our transportation is limited by number tonnage. So we have to always remember after dismantling, transport weight should not be more than the transportation weight. The site and maintenance can be designed that easier to access all these accessories. Now oil field design biggest disadvantage is that is cooled by oil which is flammable and hazardous. Now flash point of oil is 139 degree and operating temperature of class A insulation is 110 degree. So it is hardly 20, 25, 30 degrees difference in that. So any flash, because loose connection or anything, any flash in electrical joints, it will catch fire. So it is very, very dangerous because oil flash point and your flash creates 100 degrees centigrade temperature, immediately the transformer can catch fire. So this is the most negative point of an oil field transformer. So we have to be very cautious that our operating temperature should not cross 110 degree class A, or that's why specification is reduced to 5 degree less, so that immediately we get alarm and trip and isolate the transformers. Next. In case of fault when transformers, any flashover electrical device around it, there lies every chance the oil is catching fire. So it is to be installed far away from the load. It has to be away from the load in the switch here, so it could be connected by cables. So it is an additional cost. The cable I am buying and bus bar is additional cost for me. So if I could put the transformer in front of the load, so at least my bus bar cables, this thing would have been solved. So my project cost would have come down. So that's why this dry type transformer is coming in the next generation transformer. Is dry type. Next. Since oils absorb moisture, there's so many oil related activities. When any senior person comes to your factory, our job was to be that it is clean. First we see that there is no oil leakage anywhere. There is no dripping, nothing. We have to make it clean and dry. Next. So these are all related. Now if we can increase the insulation level of a transformer class A or next generation, next level of insulation, then all these oil related things are not there. So we have now comes to dry type transformer. Next slide. Dry type transformer is cooled by air and air force. So there is no fundamental change in electrical design, but only the cooling method. Since air is a poor cooling medium, so we have to give larger surface area so that heat dissipation is more and it can get sufficient air to cool the temperature. So, however, since air is cooled medium, so compared to oil, surface area of heat dissipation is going to be 2. So size of the transformer goes up in dry type. But if you consider the radiators, conservator, all these oil related things, so in case of distribution transformer or up to 10 MVA, 12 MVA, size is more or less same. Next. This calls for design of core and winding with lower. So we have to basically concentrate in dry type transformer. The design that heat generation itself is less. So we design the transformers with less loss means less heat generation, less your current density and less flux density will give you the heat generation itself. It will be controlled by that. Next. Cast resin type transformers and there are two types and backward resin impregnated dry type transformers. These are two types of there where resin, glass wool, Nomex paper and porcelain are used as the insulation. Not like your next slide. These are the 4-coil assembly of the dry-type transformer. This is the cast resin type, and this is the vacuum resin impregnated type. In vacuum resin impregnated type, resin is used as the rigid body. That means it is not act as an insulation. Insulation is done used for that Nomex paper, glass wool, and all this type. It is a high grade of insulation, class C type, but we declare it as a class F and class H insulation. And here cast resin is also as an insulation as well as the rigidity of the transformer is formed. So these are the dry type transformers look. Next, we use the vacuum resin impregnated. Here the all things, there is nothing flammable kind of things available here except resin. The resin, your flash point is much more higher compared to oil, so there is no problem with that. Next, so it looks like that. It just look like a panel. There is no oil related activities in that. So it is a very clean, environment is friendly, and it is called green transformers, and that does not give any activity related to oil. Next. However, the design point of view, it has a limitation. It can go maximum up to 10 to 12.5 kV and up to 33 kV class transformer. So large type transformer now have to be well and type only, and it has to be installed in the switchyard. Lots of improvement is also observed in the case of well and type transformer also. We have tried that. Next. Instead of mineral oil, we are now come with the ester oil. This is the next generation transformer, the ester oil. There are two types of ester oil. One is natural ester oil, and one is that synthetic ester oil. So this is basically increase the life of the cooling medium, so that you need not have to take the transformer out for this. Hermetically sealed transformers are there. You don't need to do anything. Aluminum foil transformers, I have already said about it. Now SCADA. Now SCADA provisions are there. Here all the inputs will be coming to the controller. Whatever is happening to the transformer, you get probes into design in that, so that you get all the information of the health of the transformers with the SCADA monitoring, and you get everything in the computer control. Next. High grade CRGO has come to reduce the loss, that is called ZDK, and MOH grades, these are reduce the low loss. Core building by step lab joints, but leakage flux will be less. These are the all production activities where we can this thing. Now, conservation is also coming with the bellow that gives the exposure of oil to air is controlled by the air bellow. So air is not coming directly in the conservator in touch with the oil. So oil life goes up. So your filtration time increased. So that is now being provided in the conservator, so that no direct air contact is available with the oil. Next, thermosiphon filter. Now, you see during the cooling operations, there are so many insulations are there in the DC, so that comes in contact with the hot oil. So there a sludge formation takes place, and online, if this instrument is placed, it will will go pass through this thermosiphon filter and takes the sludge out. So every after periodical, you can change this thermosiphon filter chargeable with alumina, and you can put this oil like more. Next. These are the routine tests. What is to be the routine test is basically every transformer is tested at factory, and it is the routine test is for manufacturing test. Whatever the design data has been provided, whether it has been tested as per that or not, that is to be compared with the routine test. Type test is a design validation test. Whatever design I have done, whether it is passed as per that or not. So we go for the routine test plus temperature rise test, that is also as a different test. Now, special test is the destructive test. That is called dynamic short circuit test and switching impulse test. Now, switching impulse test now has become the routine test for the high level, this 440 volt, 220 kV transformer. It has become a routine test. The short circuit test is like your heart failure. It can survive 3 short circuit tests, but it can fail at 1 circuit test. But interesting point is that the short circuit test is the validation that of your design, that it has been made suitable for that particular fault. So that particular fault leveling happens in the circuit, it will be able to withstand. Earlier it was for 1 second suitability, now it has gone up to 3 seconds suitability. So design has become much more critical again. So dynamic short circuit test, but sometimes customers also ask, I can want to do it short circuit test. It is like you are going to test in your driving car, all these things, when the accident will take place, all the balloons will come out. Are you going to crash your car and see whether the balloons are really coming out or not? So it is like that. It is a basically sample of the design test. Only one transformer is being done of that batch.
These 3 seconds withstanding capacity, which industry is asking for?
All Mecon, Mendoza steel,
Steel,
basically steel.
These are done where?
It is done in the CPRA Bhopal, but some ratings, 500 MB and all these things, what is now out. India doesn't have the capacity. Bina is, I think, is trying now. Otherwise, it goes to Germany, Kima, Holland, sorry, Kima. Those transformers are tested for short circuit 500 MVA. They do not unload from the ship. It is stationed in the ship. Ship goes to the, this one, Kima. They are the international authority to test. Only they are permitted to carry out this short circuit test.
So this destructive short circuit test.
Yes. You survive, you survive.
Once you contact, that will spoil
No,
the transformer.
I think he knows. Normally it is like that. Ideally, if you order 10 transformers, after that one will be there, and it is on the reduced load you have to use. It is sometimes like you have suffered. I have suffered one heart attack. Doctor will give you a lot of do's and don'ts. I don't go for marathon run in this thing. Lot of do's and don'ts they give.
That is taken care in the pricing.
Yes,
Pricing.
that is the commercial part. But another less important thing here. It has already suffered one heart attack. All these tests are carried out 1026. Next, maintenance schedule. I am not going to elaborate on that. There is an hourly maintenance schedule. There is a daily maintenance schedule. There is a quality quarterly is there. Next, there is a yearly, and there is a 5 next. There is a 2 years gap. What are to be checked? There is a 5-year gap. Next, and we always suggest that in spite of filtering oil, you must change the oil after every 5 years. Because it loses its acidity content, it loses chemical content. Although you will be getting BDV, but insulation, this characteristics will be right down. So better, and do not mix new oil with the old oil, because ultimately this thing will be very quality will come down. It is something like you are putting 1 drop of lemon drop in the milk, it will spoil it. So all the periodic and all these things are there in the guideline. I'm not going to elaborate on that. Next, there are various alarms are there. These alarms must be accepted. You see, in that's why I'm saying it is almost like human body. A lot of people say, I've suddenly got a heart attack. I've suddenly got this thing. I don't accept that. I accept it with a pinch of salt. Body gives a signal. Either I don't accept it or I defeat it. I get some signal that my health is not right. Similarly, here transformer gives an before failure. This not suddenly happen. Some instrument, some protective device are giving you a signal. Whether you have defeated because the production cannot stop the production, molten metal has come out from the steel, so it will be frozen. Loss of this thing will happen. So you run the transformer. So that is, of course, there is not permission by the transformer manufacturer. Next. In case of severe fault alarm is not attended, transformer gets tripped by the tripping circuits. This leads to power shutdown. And it is very undesirable situation. Possibly it should be avoided. So you have to attend.
Conclude it.
Yeah. So these are the basic things of the fundamental of transformer. These have been module has been prepared looking at the students only. We have not got elaborately on the design aspect of it. Transformer, I can tell you only one thing. Transformer industry is booming at this moment. India needs power several megawatt at this moment. And all the transformer industry order booking is fantastic. You don't get a delivery from a renowned transformer manufacturer not less than 1 year. So you can understand what growth is coming in India as in everybody is flushed with orders. So if you get an opportunity in transformer industry, you get the pulse of all the industry, what is happening in the country. Because you need power everywhere. Even if you go for the small scale industry, your personal requirement, housing, everywhere, you will get power. Power is the most demanding now in India, and every transformer industry is in this thing. So it is primary importance that we should address this thing. More opportunity comes, take care of this, encash this opportunity. Sooner or later, wherever you from there, you try to get that opportunity encashed from these electrical industries. Is going to, after that, the further development will take place. Once power is available, other development will take place. So thank you very much. Thank you for taking care. Sure, sure.
Even a time is passed.
দেখা যাবে
Thank you very much, sir, for your this insightful talk. And we have learned many things from the perspective of the manufacturing industry of transformers. Thank you very much, sir. Now I would like to request Professor N.C. Day to present. So then I would like to request our Professor Kaushik Mukherjee sir to give a flower bouquet to our respected speaker. Sir, please.
My pleasure.
Thank you very much. Thank you all for giving me this opportunity. This is my alma mater. I really feel excited. Whatever way I could give him that. Thank you very much.
Now from the GAABESU, I will request Sri Malay Niyogi sir to give a small token of gratitude to our respected speaker.
Thank you. My friend,
Yeah, I have so many friends there who are from all core sectors, power sector and BHEL, PGCIL and POSCO and other sector, NTPC. Those are very experienced. All are more than 45 year experience, and they will also come to join with us sometime if we call and we will share their experiences.
Yes, obviously. We will also learn from them.
We are thankful to HOD Madam Anandita and also Roshni Madam and our Sam. Kushit Sam also. He also did a lot. Mukherjee also here. So really thankful. Thank you all students. Please come on us. Anything required, any questionnaires, you please pass on to us. If possible, we will answer it. We'll be in touch with you for your guidance and all that. Thank you all.
Yes, thank you. Now from our department, again we want to felicitate our speaker by our HOD Madam.
Thank you, madam. I just can't
Thank
express
you,
my
thank
feelings.
you very much.
I just can't express my feelings. Those who are student today, if you in future if you come back like this, then only you understand what feeling I'm carrying home.
Thank you, sir.
Thank you.
Please have a cup of tea or have the and also some.
Please take your packets,
Please
sir.
Madam, you're in a hurry, I know.